Hey, this question is quite interesting because it talks about the two parallel um, this wire carrying the current straight into the page. All right, as seen by the question over here. Right, straight wires carrying current into the plane of the paper. In which direction is the force on Q? All right, so over here they are actually providing you with clues on current and force. Okay, so we have current, we have force. The next thing that to think about is actually the magnetic field lines, which I can see they have drawn something over here. Okay, so to know the magnetic field lines, you can use the right hand grip rule. And yep, okay, the field lines is actually turning in a clockwise direction for both the wires. All right, so how does it look like when we have two wires producing the magnetic field lines in a clockwise direction at the same time? All right, there'll be something like this. The answer is actually right. This is the pattern of the two wires carrying the two wires carrying the current into the page. All right, you can see that both the wires have magnetic field lines rotating in a clockwise direction. Okay, and you can see that some of the field lines in between the wires are cancelled off because they are moving in a direction that is opposite to each other. Okay, so in the very simple explanation, okay, this pattern of field lines actually causes attraction between the two wires. Right, this is very simple, right, and it's a similar case for two wires carrying current out of the page because the field lines are also moving uh, in a anti-clockwise direction, but in the middle they are actually cancelling each other. They are actually cancelling out each other. Okay, so the only case that causes repulsion basically is one wire carrying the current into the page and the other one is actually carrying the current out of the page. All right, the field lines at the center will actually merge and become stronger in the center. Okay, so but what exactly is the mechanism that causes the attraction and the repulsion? All right, this one we have to go a little bit deeper. Okay, this is a more detailed diagram. Right, this shows a wire actually carrying the current in a similar direction or in a parallel fashion. Okay, you can see that in this diagram, okay, on this wire, the current, oh no, sorry, the magnetic field is actually drawn for you. Right, so when the wire on the left is actually generating a magnetic field, it actually interacts with the wire on the right, which has a current moving. Okay, so according to the Fleming right hand rule, right, this is a rule that we have to use when this current is actually interacting with the magnetic field lines, it will cause a force to be experienced. All right, so try using your Fleming right hand rule, okay, for this wire. All right, and the field lines when it's interacting with this wire basically is actually okay going sort of into the page, okay, in for this example. All right, try it. Okay, you can see that actually, all right, the current is moving upwards, and then after that, okay, the field lines is basically this one, okay, because when the field lines is actually coming to the wire, is actually acting in this direction, and you will get a force acting this way. All right, if I were to switch the wires around, basically it's the same thing that will be happening. All right, if I were to actually draw the field line of this second wire, alright, and these field lines will be actually interacting with the wire on the left. Right, by using Fleming left hand rule again, you will actually get a force that's pointing inwards. Alright, this actually causes the two wires to be attracted because of the interactions of the magnetic field and the current. Okay, and they actually interact with each other. Okay, so this is very interesting. So two wires carrying current in the same direction will always cause attraction. But if one wire is carrying the current inwards and the other wire is carrying the current in the opposite direction, then it will always cause the wire to repel each other. Okay, due to this electromagnetic effect. Okay, so that's the explanation. All right, so basically the answer is actually D. All right, this is actually moving towards the other wire.